let's get started. My name is Jolanda Verhoef, and I will be joined later by my colleague Thomas. Our approach to AI on Android is based on 3 core pillars. So first of all, the Android operating system is evolving into an intelligence system, and you can expose your app's capabilities to that system. Second, you can bring intelligence into your app using cloud and on-device models. And finally, you can use developer productivity to use intelligence to build your apps. Now, together, these 3 pillars represent our commitment to embedding intelligence throughout the Android ecosystem. And while all 3 of them are crucial to the future of Android, today I want to focus on this middle pillar. So together with Thomas, we're going to make sure that you learn everything about in-app intelligence today. Now, if you want to learn more about the other 2 pillars, you can watch What's New in Android to learn more about the first pillar, the intelligence system, or you can watch What's New in Android development tools if you want to learn more about developer productivity. Now, for today, we're going to, at a high level, cover 5 different areas. So I will start with on-device inference, and then Thomas will be here to talk about cloud and to talk about hybrid inference. And I'll be back again to talk about agents running in the cloud and how you can connect to them. And then finally, we'll have a sneak preview into running agents on device. So how are we going to talk about those? Well, what we want to do is we want to take a travel app called Jetpacker, which our team has been building over the past weeks/months. And we're going to start with a very basic travel app. And throughout the talk, we're going to make that more personalized, intelligent, and agentic. And so right now, the app already looks quite nice, but it isn't yet using the newest intelligence APIs. So I actually have the app running on my device. So without further ado, let's have a look at it. So let's have a look. We should see my phone. There we go. And as you can see, we have the Jetpacker app running there. So let's open it up. And you can also see in the right top of my screen that I'm actually currently in airplane mode, so I don't have any internet connection. And as you can see, I have my current California trip right here. We can look at our upcoming trips. I'm going to Ireland later, and then later this year I'll be in Paris. And we can have a quick look at our past trips as well. So here we have an overview of all our trips. We can go to our itinerary screen to have a deeper look at what each of the days looks like. And then we can also go to the details screen as well. So far, so good. Basic app, but it isn't yet using any form of intelligent APIs. So let's go back to our slides and have a look at the first feature that we want to build. So during today's session, we're going to walk you through not 1, not 2, but 7 different intelligent features. And so I think we should just get going with the first one. So for our first feature, we're going to look at our itinerary screen. We know from our users that that screen can actually be quite overwhelming, especially when you have a long trip coming up. There's a lot of stuff happening. So what we want to do, we want to create a card at the top of the screen that summarizes the upcoming trip, and that includes some information on how the user can best prepare for that trip. So for this, what we'll do is we'll access a model, and we'll give it some input, and we will get some output. So in this case, we will give it the full trip itinerary, and then as output, we will get a short summary, and we will get some tips on things to pack and phrases to learn. So this setup is actually a great candidate for using an on-device model. It has shorter input, it has shorter output, making sure that that on-device model can run really fast. Now, when you use an on-device model, of course, you have no additional cloud inference costs. And we don't have to worry about internet connectivity, since the model is going to be consistently working even when we have spotty internet or if we have no internet connection at all. And given that we're traveling, that's quite a nice feature to have. So if we're going to want to build with on-device features, we're going to have to use Gemini Nano. Gemini Nano is Google's most efficient model that is optimized for mobile devices. We first introduced Nano a few years ago, and by now we have over 140 million devices running versions of Nano. And our latest version, Nano 4, is based on the same architectural foundation as the recently released Gemma 4 model. and then got further optimized for maximum battery and performance efficiency. Now, Gemini Nano 4 is coming to consumer devices later this year, but as a developer, you can already preview and prototype with it. And so, for today's demos, we're going to use Gemini Nano 4 for our use cases and show you how capable that model actually is in a whole range of different scenarios. So let's dive right into our code using the Kit GenAI Prompt API. This API gives us access to that Gemini Nano model that runs on device. So with this API, we simply take our trip itinerary, and then we add it to our prompt, and we ask our model to generate a summary of our trip, along with tips on preparing for the trip. Now here what I did is I just wrote a prompt myself. I just sat down, thought, what would I ask this model? And that's great, but we kind of want to iterate on that. It's always good to kind of test out a prompt before you bring it to production and kind of see how you can make it fit well with your use case. So let's switch back to our phone and let's do just that. So in order to do that, I'm going to actually close my Jetpacker app for a second, and I'm going to go into the AI Core app. So as you can see, there's an app here that's called AI Core. And you can get that app if you join the AI Core developer preview. So this is not something that every Android user sees, but if you join the developer preview, you get access to this app. It is available on all devices that support AI Core. And if you don't have a physical device with that model running, what you can do is you can actually also go to Android Studio and you can use the Gemma 4 model there. So let's have a look at the AI Core app. As you can see, we have Gemini Nano 3 there, but we also have Nano 4 Fast, and we have Nano 4 Full. So here we can choose which of the models. Now, I already downloaded them, just to make sure that this talk isn't taking an hour on this Wi-Fi. So let me open the Fast model and have a look. So let's start with the prompt that I thought of myself originally. So I just copied it over, and I put in my Paris trip. So when we do this, as you can see, this is generating a response, but it's generating quite a long response, right? This is taking quite some time. There's a lot of information, and we were trying to make things easier to parse for our users, not more difficult. So we want to make sure that we're not spending this much time generating this much text. So this is where we start iterating. Now, I did some of that iteration, and I actually came up with the final prompt that might be useful for you. For us to look at. So here what I did is, let's first take a look. We got a very fast response. And as you can see, I added a little bit more kind of guiding for the model. So I told it to use one sentence, less than 15 words, etc. And this is kind of a good way to guide the model into the response that we actually want to have. And with that, you could see that it started immediately generating a response. And it took only, 1.6 seconds to generate it. Now let's have a look at that in our Jetpacker app. So I'll go back to the app, I'll go to my secret debug menu, turn on the feature, and I'll go to my upcoming Paris trip. And pay good notice, because this is going to be fast. So there we go. We immediately have it coming up. Amazing. Let's switch back to our slides. With that, we can mentally prepare for our trip, and we can move on to our next feature. And for me, if I'm traveling, one of the things that I really don't like to do that much is budgeting, and is managing how much I'm spending on souvenirs, on food, on all those things. So I usually end up with like a whole bunch of receipts that are all in my backpack and in my pockets, and then I have to sort through and tally all of them. So for such a tedious task, wouldn't it be nice if we had AI to help us with that? And since receipts might contain sensitive information like credit card numbers and addresses, this is another great use case for using an on-device solution. So users can be confident that private information will actually be processed locally on the device without any of their data being sent to the cloud. Nano 4 excels at multimodality. And so this especially includes image understanding for tasks like OCR and visual data extraction. So naturally, it will excel at extracting information for our receipts as well. So let's have a look at how this works. In our last example, we only passed in a text prompt. But in this example, we'll pass in both a text and an image to be processed. And then for our text prompt, we will specify that we want 3 pieces of information here based on the receipt. We want a generated title, we want to get an amount, and a category. And to make sure that the returned result is consistent, we'll also tell the model that we want it to return a certain JSON object. So let's see this feature in action before we continue with the slides. Let's go to our phone, and let me quickly turn on this extra new feature. I have to shake my phone in order to go to the debug menu. There we go. I'll turn on the expense management, and I'll go to my current trip. So we'll go to the California trip. And actually, this morning, I was very, very tired because I'm from the Netherlands and I got a jet lag. So I got someone to bring me a coffee, and I actually got the receipt. So let's take an image of that receipt. So I here have my expense menu. I already went for dinner. I already did some stuff while I was here in San Francisco. But now let's take a picture of our receipt. Here we go. Say hi, everyone. Yay. And let's take a picture. There we go. And this is taking a little bit longer because for this I'm actually using the Gemini full model. So you saw that we had a fast and we had a full model. And in this case, we want to have that full image recognition, so we're using that more complex model for us. And as you can see, it recognizes that we did an espresso blend purchase, which was $5.94. That is correct. Amazing. Cool. Let's go back to the slides. I'm always so happy when demos actually work. This one was the scariest one, but hey, there we go. And as you saw, this is already working pretty well, right? But you might have noticed that we had to explain to the model what kind of fields that we need, and we had to give it a JSON example of what that then actually looks like. And then after we wrote that whole prompt, we then had to go and parse the return data, which we hope is that JSON, into a data class that we can use in our app. This is a lot of manual steps, and all of those manual steps can go wrong. So it's kind of scary. And this is why we're introducing a structured output API. This API is going to land soon, but let me give you a quick sneak preview into what it will look like. So with our structured output API, we can mark any data class as generable, and then we can further describe the class using guides for each of the properties. So these annotations basically guide the model and tell it what kind of data it should generate. If we do this, we can actually now, for our request, simply simplify our prompt. We don't have to guide it anymore there. And then we can use the method called generateTypedContentRequest that takes the parsed receipt class name to restrict what the expected output should be. Let's make sure I don't lose my receipt. And now our response simply contains this parsed receipt instance, or it will return null if it wasn't able to find one. So with structured output, we can be more confident about consistent outputs, and our code is much, much simpler with Kotlin data classes that integrate seamlessly with the Android codebase. Now, during this talk, we prototyped some pretty cool features with on-device APIs using the latest Gemini Nano 4 preview model. But this is just the start. We already have seen lots of apps using the Prompt API in production to leverage the power of Gemini Nano for use cases such as classification, summarization, content inspiration, those kind of things. If you want to learn more about how you can get the latest in on-device Android, you can check out this talk, where we are going to go more in depth on how you can ship on-device use cases to production. Next, I will hand it off to Thomas, who will walk you through the next couple of features.
Thank you, Jolanda. So, yeah, Gemini Nano 4 is pretty impressive, and it's really exciting to see how on-device models are getting better and better every year. So we talked about Gemini Nano that is basically optimized to run on your Android device efficiently. But sometimes you have use cases that require an AI model that has either a greater world knowledge or a much larger context window, or sometimes even the greater abilities in handling complex tasks. So let's take a look at what we can build with these cloud models. So we are going to use them to build our next feature in the Jetpacker app. So we are going to build a museum assistant. So it will be a chatbot that is powered by Gemini Flash and enables you to ask questions to plan your next visit to, let's say, Le Louvre Museum in Paris. So first, you need to add the Firebase AI logic to your project. And once you do that, with just a few lines of Kotlin code, you can directly call the Gemini models that are running in the cloud. You will start by instantiating a generative model, and you will pass the specific version of Gemini that you want to use. And then you basically just have to call start chat to create a chat. And the cool thing about the SDK is that it will actually manage the chat history for you. So the communication between your app and the model is actually fully handled by the Firebase AI Logic SDK. There are 3 series of Gemini AI models that are running in Google Cloud that you can use. So there is Gemini Pro, which is really good for complex tasks. There is Gemini Flash, which has a very low latency. And there is Gemini Flashlight, which offers a really good intelligence-cost ratio and also has a very low latency. So we want to build a chatbot that is really knowledgeable about the museum. And earlier I mentioned that cloud models store massive amounts of word knowledge. So you can assume that Gemini already knows quite a lot about Le Louvre, but it doesn't necessarily know everything there is to know about it. So, for example, if you ask the model about the current temporary exhibitions that are happening at Le Louvre, the chatbot will basically tell us to go to the website and search for it ourselves. So it's not super helpful. So what we can do to prevent this is use a technique called grounding. So in the context window, which is the full input that is passed to the model, we are going to add some relevant content to help the model answer the user's query better. So grounding techniques are also used in the context of retrieval augmented generation, or RAG. So you can implement it yourself, but we also made it easy for you with the following APIs. There is URL grounding, which enables you to use a document at a specific URL. There is Maps grounding, which uses the data from Google Maps. And there is web grounding that is using real-time web data. So let's see how we can use them. We are going to start with URL grounding. So let's imagine that you want to prioritize some data from a specific page that is hosted on the web. So you will start by adding the URL context tool to the list of tools when you instantiate the model. And then in the user prompt, we will tell the model to look at the specific page at the URL to ground the response. And so you can see that here we are actually using the FAQ URL of the museum. So here we are only using one URL, but you can actually use up to 20 URLs per request. And so now, if we ask the chatbot about, for instance, criteria to get discounted tickets, for example, Gemini is going to actually use the content of the FAQ page to answer. So if I say, for example, if having a cat named Mona Lisa grants you a discount to get a ticket at Le Louvre, you will see that basically the chatbot is saying no, and as accurately outlined in the FAQ, that is not enough to get a discount. If we want to give the chatbot the ability to retrieve some information from Google Maps, we can use the Google Maps tool. So that will, for instance, enable the chatbot to search for cafes or restaurants around the museum after our visit. So if after adding the tool, when I ask what are best restaurants that are good for children next to the Louvre, we will actually get a pretty comprehensive response from the chatbot. It will query the data from Google Maps and return a list of restaurants. And it's actually anchoring on restaurants that are clearly known for having a children menu. And so we can also use web search grounding to, for instance, let the chatbot search for more recent information on the web. So we now have a pretty competent museum chatbot to enable us to prepare the visit. And so the cool thing is that we built all of that with Gemini Flash and Firebase AI logic. And actually, the Gemini Pro and Gemini Flash models are perfect to build, let's say, the first iteration of your AI feature. So whether you need multimodal understanding, JSON generation, function calling, or even image generation, you can quickly build everything in Kotlin without really needing any server code or any backend resources. And the cool thing is that if your feature actually doesn't rely on your own backend infrastructure, you can really go to production with it and scale it. You can use AI monitoring features in the Firebase AI Logic SDK. You can use server prompt templates and app check and basically scale to your whole user audience. And if you think about it, you probably already have some features in your app that are good candidates to use Gemini and Firebase AI Logic. So I strongly encourage you to look into it. So it's actually used already by hundreds of apps in production. So for instance, the Redbus application, which is a ticketing platform, uses the Gemini audio understanding capabilities to create a voice-first multilingual review system. It's also used by Carrot, which is a marketplace app that basically uses it to translate messages between buyers and sellers. Gratitude, a journaling app, is using it to suggest journal entries. And finally, Ultrahuman, which is a fitness tracker app, is using it to build a logging feature, food logging feature using the Gemini image understanding capabilities. So a lot of interesting use cases. Okay, so let's take a step back for a second. So we saw that many of you want to build with Gemini Flash and Gemini Pro using cloud inference. And earlier, Jolanda showed all the cool things you can build with Gemini Nano on device. But we also heard some feedback from you. You basically need to support users on devices that don't necessarily support Gemini Nano just yet. So what if we could just combine both, right? That's actually the promise of hybrid inference, and I think I have a really good use case for it. So reviews are a pretty key element in most Android applications today. So in your app, maybe you're asking your users to rate other users or rate a business or even a piece of content like, I don't know, a song or a show. And so you're often asking your users to basically write a review. Or sometimes you're even asking users to post a review for your application in Google Play. And it's important for you, but it can be sometimes tedious for your users. So we think Gemini Nano can actually be super helpful for that. But you also need to have this feature available on devices that don't support Gemini Nano just yet. So in the Jetpacker app earlier, the chatbot museum recommended restaurants. And so what if we were to implement a restaurant review feature in the app? So here you can see that we have a list of topics to choose from about how we basically felt about the restaurant. And we will let the model draft the short review for us. And the user is always going to be able to edit it later before posting it. So here you can see we are selecting some topics. And once we're done, we are clicking on generating the review. And basically, Gemini Nano, if Gemini Nano is available on the device, the review will be generated by Gemini Nano. But if not, it will default to Gemini Flashlight in the cloud. So it's completely transparent for the users, and it's also very easy for you to build as a developer. So to build this, we are actually using the latest API from Firebase AI Logic. So to do that, you need to add the on-device Gradle dependency to your app dependency, to your project. And then, so you can see here that we basically generate a review with a prompt that is interpolating the selected topics. And then when we instantiate the model, you can see that we are passing an on-device config object, where we define the inference mode that we want to use. So here you see that we are saying prefer on-device, so we will prioritize on-device inference. So this API supports 4 inference modes. So there is prefer on-device, prefer cloud, And there is also only on device and only cloud. And it's actually available today, so you can try it out, and you can learn more about it in the Firebase documentation. So we just talked about a very simple routing logic. Here it's basically two criteria. Is Gemini Nano available on the device, and is the device online? But sometimes you want to build something that is a little bit more complex. So you can imagine having a pretty advanced custom routing logic. So for instance, you can monitor the system health of the device, and you can decide to use a cloud model if, let's say, the CPU is overloaded, or if the battery of the device is below a specific threshold. And another thing worth checking is also the latency. So if the latency is above a specific threshold, you can decide to focus on device. Another thing, too, to keep in mind is that not every single query requires a very advanced model running in the cloud, and some do. So it can be interesting sometimes to use a lightweight LLM, like, for instance, the Gemini 3 model that is only 270 million parameters, to basically route those queries based on their complexity. And at the end of the day, I'm just listing 3 criteria here, but there are many other criteria that you want to take into account based on your app's needs, or also the user experience that you want to provide. So if we go back to the Jetpacker app, let's say that we now want to implement instant messaging translation for a chat feature between the hotel staff and the customers. So the customers and the hotel staff will basically use their own language to chat, and will use the AI for translation. So let's see how we can use hybrid here. So let's imagine that we want to prioritize on-device to save on inference cost. We also want low latency, so we provide a really real-time experience to the users. And we also want to make sure that we basically support as many languages and on as many devices possible. So we know that on-device translation capabilities are getting better with Gemini Nano models. But we also want to be able to fall back to the cloud if the model doesn't support the language. And so in this case, we'll use Translate Gemma, which is an open-weight model based off of the Gemma model that can be potentially fine-tuned if you want. And so here is the inference stack that we are going to use. So for on-device inference, we will use Gemini Nano models through the Kit Prompt API. And for the cloud inference, we will use Translate Gemma that will be hosted on Google Cloud. And we will also use the on-device Kit language identification API that will be able to detect the language used in the conversation. So we will implement the appropriate routing logic based on the version of the model that is available on the device, the language that is used, and also the latency of the network. And so here in this diagram, we are basically implementing the routing logic in code, but there are already experiments to use AI to actually define the routing. And in a minute, Jolanda is going to show us how the agentic approach can help us with that. So let's see the translation feature in action. So let's say that I'm typing in Dutch, but I'm basically talking to a hotel in France, and the staff speaks mainly in French. So I will send my message, and I will receive a response that basically enables me to translate using hybrid inference, translate the message in Dutch. And on the other end, the staff can also have the same setup where they can basically translate the message that was sent by the user to their language. And so here, the translation will either be on the device or on the cloud based on the criteria that we talked about before. It will be, again, completely transparent for the users, but we'll have a very high-quality translation feature that is running via hybrid inference. So this custom hybrid inference approach is already used by several applications in production. For instance, the Gboard app is using that. It's also used in the Pixel screenshot application. And the Kakao Mobility app also started using it. And so with that, I will pass it back to Jolanda to talk about agentic systems.
Thank you, Thomas. OK, for our next feature, we want to take our app to the next level, and we want to connect it to our cloud backend. So we have a Jetpacker backend running in the cloud that is able to reserve flights, hotels, and activities on our users' behalf. Now, in our app, we simply want the user to be able to go to the booking screen and then automatically kick off that booking process. And it will automatically book all the things that that user wants to do. And then the booking process will be running fully autonomously. And our Android app is just showing the progress of all of these different booking agents working. And it will let the user provide input when needed. So before we show how we can build this, let's go back to the phone and look at it in action. So in order to run this, let me first turn off my airplane mode, because we have a backend this time around. So we have internet going on, I hope. And we'll open our Jetpacker app again. And we'll turn on the booking assistant. There we go. Now, if I open my current app, let's say, or my current trip, I can go to the booking screen, and I can start our booking. And as you can see, it is connecting to our booking server. Now, while this is connecting, as you can see, this is taking a little while, because I need to connect to this server that is running, that is doing a whole bunch of stuff. I do hope it will connect in time before the end of the talk. It might be that my Wi-Fi is not as strong as I was hoping it would be. Look, there it is. OK, amazing. So as you can see, what we did is we basically just sent our itinerary to that server, and it started up a session for us. And it's then kicking off all of these different booking agents for me. So it's kicking off 4 agents to run to book activities. So here I see like my lunch and my dinner and like all kinds of bookings there. Same for my hotel, and then the same for the flights. But all of those need some kind of information from me. So for example, let's say that for my SFO to Amsterdam flight, I will confirm that indeed that is the right time frame for me. I can confirm the selection, and I get to choose a chair. However, in the meantime, while all of these agents are running, if I'm not doing anything else, I quit the app, I go do something else, and I come back tomorrow, and I come back into the app, I can reconnect to that existing session. So now if I go back to my ongoing connection, as you can see, it will just reconnect, and it will like find all of those agents that were running, and if surely it should show all of them. It is, again, maybe not the fastest Wi-Fi here. But in the meantime, as you can see, it's still asking me, it still remembered where I was in the process, so it's still asking me for that seat number. So I can confirm that seat number, I can say I confirm my whole booking, and there we go. As you can see, I think my internet is fully out now, but this would normally show the full confirmation, and we'd be done. There's not a full talk that you can do without having like one demo hiccup, right? So this is the one. I already assumed it would be the one where I'm actually using the internet. So this is why we have on-device inference people. OK. So before, Thomas was already speaking to you about Firebase using a managed backend. And this is ideal for getting started or when, as a mobile team, you want to develop in isolation. And it provides and focuses on direct client-to-model inference, which makes it kind of fundamentally stateless. And so for our trip booking, we instead use a custom self-hosted backend. This server, which we fully control and gives us full flexibility. And so when we book sessions, even when the user closes the app, that system can just continue running in the cloud. It also gives us complex multi-step orchestration, and because it's running in our own backend, it gives us access to our company's data. So how would we architect such a solution? Well, if we go and take it all the way back to its core, we basically have a cloud backend and we have an Android app. And they somehow communicate with each other. Now, we want that to be basically a server or a event-driven communication that goes both directions. So some ways of doing that transportation would be to use server-sent events or to use WebSockets. Then we have our connection set up between the two, but then what do we run in the backend? So we wanted to have a complex multi-agent booking system, and we chose to use the Google-built ADK, or Agent Development Kit, which is a flexible and open-source framework for developing and deploying AI agents. Now, for Android developers like you and I, it might be a little bit scary to look at backend systems, and it might be a little bit intimidating. But just to give you an idea, let's actually look at the implementation of the backend that we wrote. So we can define an agent by setting their name, giving them the model that they should communicate with, giving them an instruction, and then giving them a set of tools. That's all we need to set up like one simple agent using ADK. Then we can make a top-level orchestrator that can delegate work to several sub-agents. So here, for the restaurants, for the hotels, and for the museums, I'm making a bunch of different sub-agents. So when we have such a backend set up, there's one question that remains. It's running in the cloud. We have an Android app. How do we communicate? What kind of messaging protocol do we use? Now, we could be making our own. We could set up our own kind of communication pattern, decide what are the requests that we're sending, what are the responses. However, once you start adding more complexities to such a backend system, it can become quite unwieldy and difficult to deal with. So instead, we can use the AGUI protocol. This standardizes communication between agents and UI clients. So the protocol predefines a set of message types that have been designed to best represent agent-to-client interactions. So the agent can inform the client about, for example, its lifecycle events, text messages, tool calls, state management, etc. And the other way around, we can have our Android app that is sending text messages, providing tool call results, and sending custom events. Now, most agent frameworks have an AGUI adapter module, so that allows them to interact using that AGUI protocol. And similarly, there's also several AGUI libraries for clients. So for example, for Android, there's a Kotlin SDK that gives you a great Kotlin API to communicate with any AGUI-enabled backend. So as an Android developer, at that point, all that you kind of need to do is set up the connection to your backend, and then decide how you want to visualize those AGUI messages that are coming in from your server. So in our use case, we're parsing the messages that are coming in, and we're showing them in our nice UI. This is already quite great, but I believe we can do better. So if we're deciding, so the step 2 that we just mentioned, deciding how to visualize the events coming in, that is actually quite a lot of work and quite a lot of kind of like figuring out, right? It doesn't really scale that well, and there's some version dependency complexities, like what if my backend is updated, but my Android app is still older, etc. So what if instead we could have our app describe a set of UI components that it is able to render, and then let our AI model speak UI instead? So what do I mean with that? So A2UI is a protocol that allows agents to render UI in a client. It works really well together with AGUI as a transfer protocol. But the client simply informs the agent which components it can render, and then the agent that's running on the server decides what is the best UI components that I can use, the best tree, the best hierarchy, to then do what I want to do, or ask the user for input, or kind of like to reach my goal, basically. And as an Android developer, that means that the only thing that we still have to do is define our set of components, which might be composables that you already have in your app, provide them to your server, and then render them. So let's have a look of an example of what that communication looks like. You can see the component tree being passed from the server to the client to be rendered at a given point in time. And you can see that A2UI supports both basic components, like we have column and text here, but it also supports custom components. So for example, here I added support for a My Progress spinner. You can also see that we're not actually passing actual data at this point. Instead, the server is just passing variable names. And then in a separate message, after it's sent the components, it can actually give you data associated with those variables. So all of this is pretty cool, but at this point, we're just passing JSON, right? Like it's just JSON coming in, JSON going out. What does that actually mean? That's not UI on a screen yet. So how are we going to render that, specifically on Android, right? So on Android, we are currently building a Jetpack Compose renderer. It will allow you to automatically render those A2UI messages that are coming in from your server. This A2UI renderer has a set of basic components that will give you great out-of-the-box experiences, so you don't have to do anything special here. And when needed, you will also be able to provide your own custom components based on the composables in your app. So that's what we did in the app to constrain our model to generate our custom booking-related components. So now we can build beautiful UI and let the agent show specific components when, for example, we're choosing a seat. Now, in our code, we create an A2UI message processor and pass our custom catalog to it. From that processor, we then retrieve active services. And in our UI, we simply retrieve the services that are coming in and display them in a column using the material A2UI service composable. So to summarize, we have AGUI on the one hand, which is our transport layer communication protocol, and it provides an event-based communication pipeline between agent and client. And A2UI is our independent protocol that helps an agent speak UI, which can then be rendered into native components on the client side. Now, A2UI is just message passing, and it works over any transport, right? So it could also use REST, MCP, A2A, or AGUI. Now, we're at the start of these protocols, so please do give a look at a2ui.org to learn more and stay posted. OK, let's get to our final feature. So we already saw how we can connect to an agent running in the cloud. What if we want to instead run an agentic system on our device? Now, this is very early and experimental, but I did want to kind of give you a heads up of what we're thinking about and what we're developing and what we're moving towards as Android. So let's see if we can build an agentic system that hosts multiple agents that all communicate with each other, orchestrated from within our Android app. Let's switch to our app and quickly show it in action, hoping that the Wi-Fi is fixed by this point. So I'll turn the feature on. This is called the Genius Assistant, and our Genius Assistant is going to help us during our trip to understand what's going on. Now, it will first go to our cloud, and it will go and try to understand what's going on in the trip. So it passes the itinerary, and then it understands that I have a hotel and a car reservation. So let me check my hotel reservation. What it will do is it will actually understand that there's multiple agents running, and it can understand that it can transfer to our hotel agent. Now, our hotel agent is a sub-agent that runs on device because I have my personal data running on my device as well. So I have some personal information here. I have my passport, and I have the hotel reservation, and the model will actually compare the two. So here there's multiple agents running, and I'll show you later how this is set up. But this is pretty cool, and we have a way to understand that for my hotel reservation, actually, I provided the wrong passport number. So there's a lot going on here, and I'll show you how that actually works. So let's go back to the slides and dive into it. So one way of doing this on Android is using ADK for Android. This is a brand new library. We just released version 0.1 this week. And it takes all the learnings that we had from ADK on the cloud, which we've seen in our previous section, and it applies them to Android. ADK manages all the complex orchestration, context handling, and error handling for you. It allows you to build an agent with just a few lines of code, easily swap out models, etc. Now, for our trip assistant feature, we first designed a main orchestrator that uses cloud intelligence. It then calls tools to get information about the trip, chooses to offload work to a sub-agent that we run fully on device, and then each of the sub-agents runs a set of agents in a sequence and shares the data between them. So we only ever return the final results to the orchestrator that are stripped of any privacy-sensitive data. So in our code, what this looks like is we have our trip assistant orchestrator, which uses a cloud model for its intelligence and has a set of sub-agents. And we give it a tool, as we saw before, and we give it some top-level instructions. So it knows when to offload to which agent. Then each sub-agent is defined as an on-device sequential agent. And we have various retrieval agents that can use the device Nano model to retrieve the correct data from our user's document. Separately, we have that last validation agent that we saw that can compare the data coming in from those retrieval agents. And together, we have a whole set of agents set up with just a few lines of code, using both on-device and cloud, working to build something that is highly intelligent for your user. Now, as I said, ADK for Android is just starting, and we're looking forward to see what you build with it. Check out adk.dev for more. Now, with that, we completed all 7 features, and we made our app so much more useful. So while we're working on making the Jetpacker source code available to you soon, in the meantime, please go to developer.android.com/AI to learn more. And with that, thank you for joining and have a great I/O.